Welcome to Solving Systems Algebraically, Part 2. So we used elimination yesterday. But yesterday it was more convenient because you had an equal and opposite piece on either the y or the x, or you had an equal piece for the y or for the x, and all we had to do was multiply by a -1 to be able to eliminate. But it's not always quite so convenient when we want to use elimination. Like for this one, if I tried to add the system together, and let's talk about that for a minute, because sometimes people see elimination and they just start adding right away without thinking about it too much. So how about, Dylan, how about if we tried to add these right now, what will we get when we add the x's? 5x. And if we tried to add the y's, we'd get 12y, so nothing eliminated. So we want to make it so that when we add the x column and add the y column, that something disappears, that something eliminates. So what we're going to need to do is we're going to need to find something to multiply by one or both of these so that something can disappear from either the x's or the y's. And it really doesn't matter which one you choose to eliminate. I could choose to eliminate the x's, or I could choose to eliminate the y's. It works kind of like common denominators in a fraction, but it's going to be just a little bit easier than that, I hope. What we want to do is we want to multiply by something. Like, for example, if I multiplied this one by 3 and I multiplied this one by 2, in both cases we're going to get a 6. You're trying to make it an equal number somewhere attached to one of the variables. So 3 times 2 gives me 6. 2 times 3 gives me 6. And then I pick a negative because I want one of them to be negative, so when I add them, they eliminate. So do you see what happened here? We ended up taking this number and multiplying it by this one, and the other number and multiplying it by this one. And that's a nice little shortcut to make sure that you're always going to be able to eliminate. So 3 that's down here gets multiplied by this top one. -2 that's up here gets multiplied. And you just want to make sure that you end up with opposite signs so that they will eliminate. Okay, so let's go through. Notice I've just got these arrows here. It's not really a big technical thing. It just helps me keep track of, I'm going to multiply times 3 and I'm going to bring it across. I'm going to multiply times -2 and I'm going to bring it across. Now, the reason it works is because you're multiplying both sides by 3. You're not just multiplying the x part by 3, you're multiplying the whole thing, because in math, it's okay to multiply both sides of an equation by the same thing. Multiplication property of equality. It's okay to multiply both sides by -2. So when we bring these things across and we multiply, Nikai, what do you get when you multiply 3 times everything here? So 6x plus 21y equals 12. And Brandon, how about this one? Good. So he watched out for his signs. And what we do here, when we multiply them and we get our -6 and our -10 and our +10, our key thing that we're looking for is that now we're in a place where if we add them, how much is 6x plus -6x? Anybody? How much is 6x plus -6x? How much? 0. And that's what we're looking for. We're looking for it to make 0 so that it will eliminate. So now that we have it set up to eliminate, we need to do that. That one makes 0. And then we can look to see what the rest equal. Okay. Let's look at it carefully. This one eliminates. 21 and negative 10 gives you 11. And 12 and 10 gives you 22. And then after that, it should just all click into being, I've done this so many times, I know to do what? 11y equals 22, so how do you get y? You do something with 11 to both sides, which is, what is it? Divide by 11 on both sides, and we get 2. And then now that we have the y equals 2, how do you suppose we're going to find the x that goes with it? What do you think? Plug it in. Absolutely. Good job, Angelia. We're going to plug it in. Does it matter which one that we plug it into? No, it doesn't matter what we plug it into, because remember, we're finding a solution for both of them. So we just pick one. Pick the one you like best. This one has no negatives, so I like that one best, but you could pick either one. 2x plus 7y, which is 2. And then we go through and we solve it. We get the 14. Then we take away the 14 from both sides to get negative 10. And we divide by 2. Give us x equals negative 5. And that gives us our answer. And our answer is going to be the ordered pair, negative 5, 2. So there's our answer for that question. Okay. And is there anybody that still needs a little time to write something down? Okay, good. Everybody's keeping up very nicely. Good job. All right, so it doesn't matter which variable you want to solve for first. If you wanted to, wait a minute. It's not the same question, but it's kind of a similar question, isn't it? Which one did we solve for the last time? Which variable did we find first? We eliminated x, right? And we found y first. So if we wanted to, we could eliminate y first. And if I wanted to eliminate y first here, if I wanted to eliminate the y's, how could I make that happen? Any ideas? Good job. All right, so yeah, so multiply this one by 2 and this one by negative 7, because that's going to make these both turn out to be 14. So let's go ahead and do that. Multiply this one by 2 and this one by negative 7. So you're doing that on your paper. You know, you can look up to check, but I want you to go ahead and do it. This one by 2, this one times negative 7. And now that we're back, once you get it so that you've got the 14y and the negative 14y, those two will eliminate. And in eliminating them, we don't have the y's to deal with anymore. Remember, you're adding down the columns, so positive 6 plus negative 35. So positive 6 plus negative 35 gives us how much? Negative 29, good. And then this one is 30 and 28 is 58. And that's convenient because 29 is really just half of 38, which makes this one solve very nicely. There we go. Negative 29, positive 58. There you can see it by itself. The y's disappeared. Do be careful what variable you bring down, because sometimes people will bring down the wrong variable. Make sure that when you eliminate it, then that's gone, then you have it there, and then divide by negative 29, and we get negative 2. And we can go back and once again plug it back in to your choice of equations. I generally like to pick the one without negatives just so that you don't have to deal with as many negatives, but it doesn't really matter. So 3 times negative 2 plus 7y equals 15. Go ahead and finish solving that off. And then after you finish solving it, we will move on. As you were going through and you finished and you solved it using the algebra that you know, as I looked over your shoulders, negative 2, 3 is the answer that you should have gotten, so good job. X is negative 2, y is 3. That answer would work in both of the equations. At this point, we have another one that we can take a look at. Usually you'll want to pick the easiest one, just so that you don't have as much chance of making mistakes. Which one is going to be the easiest to solve for here? What do you mean by the first one? X. Because in order to solve for X, what would need to happen? Equal and opposite. So what would be the best way of doing that? Like, how are we going to make these equal and opposite on the X's? We could do that, but there's a faster way. Just multiply the top by 2. You can look for things to see if there's a shorter, easier way. You don't have to do each one by something. So for this one, if we just multiply this top one by 2, all of a sudden we've got 4 and it's going to cancel out. So go ahead and I want you to just take a minute. I want you to work through this one as best you can on your own, and then we'll talk in a minute as far as what you should have gotten, and I'll walk around and see what you need. Once we multiplied by 2, we get 4, negative 6, and 16. And then when we begin to add together, the 4 and negative 4 cancel out. We're left with negative 25y and 25y. When we divide that by negative 1, we get, or when we divide that by negative 25, we get negative 1. Then you pick either equation, plug it in. Chose that one this time. Negative times negative makes positive. Subtract 3 from both sides. Divide by 2. We got a decimal, but that's okay. We can do 2.5. You may write 2.5 if you want. You can write 5/2 if you want. Either one, any of those would be considered correct answers. Okay. So let's move on a little bit. Let's try this one and see what happens with this. 3x, everybody write it down. 3x plus 2y equals 5. Negative 3x minus 2y equals negative 5. Because sometimes we'll run into a situation like this. Are we going to have to multiply by anything to make something eliminate? No. But something should start to be kind of bothering you on this. Because what happens here? What happens with our, they cancel. What about this? They cancel. What about this? Also cancel. But they cancel. What number does that turn into? 0. So we have 0 equals 0, and that actually means something very special. Okay, now I've heard a couple things. I've heard some people saying infinite solutions. I've heard some people say all real numbers. What happens here is that the lines come out to be dependent. These are actually different forms of the same equation. So when you get a true when you're eliminating, what that means is you have infinite solutions, and those solutions are all along this line, which happens to also be this line. So a true means that you have infinite solutions. It does not mean that it's all real numbers. Okay, when we had just a single variable, it would be all real numbers, but all real numbers could be the domain and all real numbers could be the range, but it's only very specific ordered pairs that make this one true and also make this one true. So there's infinite solutions, but it's not everything is a solution. Only that there are an infinite amount of them. So if you solve down and you get everything eliminates and you get 0 equals 0, which happens to be true, the lines are dependent. Here's a word that we had that we talked about yesterday, and there are infinite solutions. So you'll need to make sure that that is in your notes. And I want to look at what happens with something similar. I'm not taking away from this slide, just adding. Here's one that looks pretty similar. These are still equal and opposite. Our variables disappear, but this side doesn't. And we get 0 equals 5. Is that a true statement? It's a false statement. So if true means there are infinite solutions, what do we think that false is going to tell us? There is no solution. And if there's no solution, what would be true about the lines? Remember, these are graphs of lines. They're parallel, yes. Okay, somebody threw out that word skew. Skew is actually if you have two different planes and the lines are not intersecting, but they're not in the same plane either. So we would need to have a third variable involved for skew lines, but we don't, so we don't have to do that. So if you don't know what a skew line is, don't worry about it, because we're just dealing with parallel in a 2 dimensions with an x and y axis right now. So this is false, which means that the lines are parallel and that there's no possible solutions to this equation. We can add just a little bit more information, or actually this is just reiterating it, because this is a little wordy. Infinitely many solutions here, no solution here. I'll give you a minute to make sure you're caught up. All right, one more thing to think our way through. If we want to solve this one, you could eliminate the x's or you could eliminate the y's. There's not really one that's better than the other, but let's get back to what we were talking about a little while ago. You could either multiply this one by what and this one by what. If we eliminate the x's, we would multiply by 2 and -3. If we wanted to eliminate the y's, we could multiply by 2 and you could do 2 and -3, or if you didn't manage to see that one, you could multiply this one by 6 and this one by -9. So you could do either one. The example that I have here is 2 and -3. But once again, if you don't happen to see that 2 times 9 will give you 18 and -3 times 6 will give you 18, that's okay, because there are other ways of solving this. Okay, if you just like to have simple rules, okay, if you like to have, and you don't want to have to look a little further, you can always just do the opposites, like this one times 2, this one times -3. That will eliminate the x's. But some of you might be saying, wait a minute, I'm starting to see something come out here. Because when you do this, it's not always just set up for you at the beginning to look obvious, like the other ones were obvious. They were going to have something cancel out. Here you had to actually do the multiplying, and then you see that everything cancels out. And what was it? What does that mean once again when everything cancels out? Infinite solutions. Good. So 0 equals 0, infinitely many solutions. So that's all of the new material that I have for today.